Hi, this is Nick from your statistics class. I want to talk today a little bit about sampling. I'm going to use this Rossman and Chance applet to help me discuss it. There are a couple of populations we can pick from. We can pick from sleep habits from a whole bunch of people. We can pick up from the words in the Gettysburg Address. What I want to do is focus on 1,000 pennies, which I guess at some point existed in real life. Picture a jar of 1,000 pennies. So this 1,000 pennies, these 1,000 pennies in the jar represent the entire population of pennies in the jar. And say we are interested in finding out what the average age or average year of the pennies is. What we could do is we could take out every single penny, one at a time, and we could figure out what the average year is for that penny, for the entire jar. So I take out the first penny, and I say it's 1995. I take out the second penny, it's 1984. I take out the third penny, it's 1970. And we get a distribution that's left skewed and looks something like this, right? I say left skewed because you've got this kind of trailing off to the left-hand side here. We would expect there to be more recent pennies, which is what we see. We expect there to be more new pennies because old pennies, they disappear. They get taken back and, destroyed, melted down. I'm not sure. Maybe they just didn't make as many pennies back in the day. Point is, there are more new pennies out there in the world, still in circulation. Looking at every single penny of 1,000 and marking the year takes a long time. We have all the data here now, but gathering all that data took a lot of effort, and we wouldn't necessarily want to spend a lot of effort on this problem to begin with. Knowing the average year of a jar of pennies doesn't seem like the most important statistical question that's ever been answered. So what we'd like to do is we'd like to sample. We're not going to look at every single penny. We will sample a smaller set of pennies. So let's look at our sampling options. We're going to focus mostly on simple random sampling in this class, and so I'll ignore the stratify and the cluster options, but you can look at those if you'd like. Let's say I want to take one sample of 10. So I'm taking 10 pennies out of this jar, and I'm doing it in a simple random way. Maybe, what does that look like for a jar of pennies? Maybe you shake all the pennies in a big jar, and you take one out, and then you close the lid, and you shake them all up again, and you take another one out. That could be an okay way to sample these pennies, I suppose. But let's say we did that 10 times. I'm going to draw them. These are the pennies we got. We got the 155th penny, that was the year 1995. We got the 252nd penny, which is the year 1982. Here are each one of the observations, or the cases, right? And here they are just kind of plotted. You might notice that these blue dots kind of match these blue dots, except for these blue dots are in the place of the actual penny. So there is this one penny here, and if we remove the bar, this thing kind of falls down and ends up over here. Anyway, if we were just trying to answer the question, what is the mean year, the average year for these pennies, we would get this statistic, based on our sample size of 10, of 87.9. Once again, that's kind of silly. We could say maybe the mean year is 88, because it's pretty close to 88. The spread of the data, this statistic, the sample standard deviation is 7.68, which is pretty far from the actual population standard deviation, which is 9.6. And here it shows our sample size of 10. Well, you'd guess as our sample size got bigger, say we go from 10 to 30, we would hope that our mean for the sample would be closer to the mean of the population. Let's see. So we'll do that again. Notice there are more cases here. There are 30 cases. You can count them if you want. Our mean is, the mean year is 1985. Let's say it's 1985. It's still kind of far, but if we make our sample even closer, or even larger, we can see that the mean gets up to 1987 or 1988, which is pretty close to this one. Again, our standard deviation is close too, and even our graph is starting to look more like this graph over here. But we have a sample size of 100. That means we had to take out 100 pennies, look at the year on the penny, and put it back. And it's trivial, but it would take a long time to get that done. Let's just play around with it a tiny bit more. Let's say we wanted to do 10 samples, and we wanted each sample to have a sample size of, I don't know, 20 or something. We draw the sample. It only shows us the most recent sample, like it did all the other ones. But if you look over here, it will show you the mean of all the samples that you got, right? So here's the mean of the most recent sample. If I click over here, oh, this is the third sample, and it shows me the mean of the third sample. And there's the mean of the 9th sample. And here's the mean of the 6th sample. Let's say let's do more samples. Instead of just 10 samples, let's go ahead and do, like 30. Let's go ahead and make the sample size 30 also. I'm going to draw those samples again. Notice how our sample means are getting more clustered here. We'll talk more about this, what's happening over here with our distribution of the sample means when we get closer to Chapter 5. And you probably are also noticing if you're doing 30 samples with 30, that's still a whole bunch of pennies. You're still looking at like 900 pennies. And that seems like it would take a long time too. So anyway, go ahead and play around with it. Look at the difference between your population parameters, the mean and the standard deviation, versus your population statistics, the sample mean and the sample standard deviation. Check out your cases, which are all the individual blue dots. And our variable here was year. That's the year. That's the variable we were paying attention to. All right. Thanks a lot. Post in the forum if you have any questions.